Hello and welcome to the demo of Quantum Connect 4. It's worth mentioning that this game was influenced by the Quantum Tic Tac Toe game that's out there. Um, we got together this week and decided to form a team and started writing the code early hours of this morning. And we're happy that we're able to get something working sent. So an overview of the project of what it is Connect Four with a bit of spookiness to it, and what that means is instead of being able to drop one disk at a time, you can actually drop two disks to represent superposition, which would mean you have a 50% chance of uh, one of your disks or both of your disks uh, existing after the circuit has been completed. But without getting too much into that, let's see what the project is like. So we're going to start it up. Um, we'll start our server. So the Python server is where the Qiskit library is running, and that's what computes the information. Um, I should probably note that the instructions are in the README of the project, and you would first install the requirements. And after you're done installing the requirements, then you would run the server. The same would go for the front-end application. You will install the requirements with, either by typing yarn or in some places npm install and install the dependencies. Then you would run the command yarn dev or npm run dev. So what this does is to actually bring up the front end of the application. So it's running on localhost 5000. And what we're going to do is reload the page and see our landing page. So it's a very minimal uh, landing page. And uh, just again to reiterate, we started coding the early hours of this morning. So let's hit play. And now it's player one's turn. So player one will drop their disk. Now player two has the ability to drop a disk anywhere. So let's say they decide to drop it out here. Now it's player one's turn again, and they will prefer to um, add some quantumness to this. So they're going to drop one disk here, one quantum disk, and another quantum disk here. So they're basically doing this as a way to get a better chance of winning. So player two sees this and also feels like dropping a quantum disk. So they will drop one here and another one here. Now, when as the game progresses, the board will most likely get filled up, and at some point, it would eventually calculate uh, if nobody wins and the board gets filled up, then the board gets collapsed. All the quantum disks gets collapsed, and the results will the resulting board will be fewer disks, um, and the players will continue. So what we can see here is that both player one and two, they have their regular classical disks on top of two quantum disks. Now what would expect to happen is, because each of these light blue disks that belong to player one, because each of them have a 50% chance of staying on the board, what we'd expect is that after we send the request to our backend using the Qiskit library, um, once we send the request and get the response of which 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 of them should be eliminated, what we'll see is one disk will fall and the other will change color to a darker blue. So let's see what happens when we click collapse. And also notice how these other two superimposed disks would also be affected. So you can see that the disk that was here disappeared, meaning that this disk was the one that was selected, and that became a dark blue, red. You can see that the blue that was on top here fell because the one beneath it was not chosen, and the one beneath this red was chosen and became a darker color. So it's now a regular classical disc. So we can keep playing the regular game, and of course we can continue to superimpose the discs. So you can pretty much feel free to add as much as you like and just keep playing. And that is our demo. Let me see if I can win this. Yes. All right. Thank you very much. The code is in the repository, the GitHub repository. And if you have any questions, we'll be glad to answer them. We hope you enjoy reviewing the code.